Hey guys, today I'm going to teach you all about slope and rate of change. These are actually both two words for the same thing. You might have also heard them called unit rate or constant of proportionality in the past. So we're just going to call it slope today or rate of change and realize that those are all the same thing. By the end of this lesson, you'll be able to identify the type of slope a line has from a graph. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. So let's start out with a real life example of a graph that involves slope. This is a graph for babysitting wages. This is how much you get paid for babysitting. So this is my little cousin October. We're going to babysit her. And for each hour we babysit, we make $10. It's a constant rate because it's a straight line. We're making $10 each hour. So after 4 hours, I've made $40. After 7 hours, I've made $70, and so on. The constant rate, what it goes up by, it's 10 each hour. 10 is the slope. So like I said in the past, we might have called that just the rate. And in real life, we probably would say this is the going rate. But in math now, we're going to call it the slope. This is just the rate that this is changing. Remember, this line represents how much money we make as time goes on. So as time goes on, we make $10 per each 1 hour. So like I just said, slope is the rate of change in a relationship. In the last example we looked at, the things that are changing is time and money. As time goes on, money increases. So slope, or the rate of change, is a ratio of the following. Remember, a ratio just means a fraction. We can say it's the change in the dependent variable over the change in the independent variable, or an easier way to think about it, the dependent variable is y and the independent variable is x, so it's the change in y over the change in x. And if you look at the last example, it's dollars per hour. Remember, this is the y-axis, this is the x-axis, so it's change in dollars per hour. So that is what slope means. It means the rate of change or the change in y over the change in x. It's always going to be written as a fraction, and it's the exact same thing as we've been talking about with rate, unit rate, or the constant of proportionality. We can also say that on a graph of a linear relationship, which means it's just a graph with a line, the slope describes the steepness of the line. Basically, that means how slanty is it. So here, it's pretty slanty. If it was slantier, if the line went up here, that would mean we get more dollars per hour. So the steeper a line is, the greater the rate of change. So let me say that one more time and just take that in. The steepness of a line tells you how slanty it is. The greater the slope or the rate of change, or how more steep a line is, the greater the rate of change. That'll be very important later on when we compare rates of change. We can compare slopes. But for now, let's go ahead and look at just the four types of slope. There are four types of slope. These are the four types of slope. Let's start with the first one. It's the one we've already looked at. It's a positive slope. A positive slope increases as you move from left to right. So just like we read, we always move left to right. When I start on the left of my graph and I look to the right, the line is increasing. It's going up. So when I move from the line, starting on the left and move to the right, the line is going up. That means it's a positive slope. It's increasing. This graph for babysitting wages has a positive slope. That means that this line is increasing. It's going up. You get more dollars for each hour that you work. As the dollars increase, the hours increase, and vice versa. The next type of slope is called a negative slope. A negative slope is pretty much the opposite of a positive slope. A negative slope decreases from left to right. When we look at a graph, we always start on the left and we move to the right. When we look at this line, we start on the left, and if we move to the right, it's going down. It's decreasing, which means it has a negative slope. So here's an example of a graph that has a negative slope. This is me on my dirt bike going downhill. This graph at 180 feet means that that's where I'm starting on the hill, and then as time goes on, after each minute, I'm dropping down. I'm dropping down at a constant rate because it's a straight line, and it's a negative slope because it's decreasing. So with each time as I move left to right, it's decreasing from point to point. The next type of slope is called a zero slope. This is a flat line where there is a horizontal line. There's no change in the slope here. It's not positive, it's not negative, it's zero the whole time. So a flat horizontal line is called a zero slope. Let's go back to the dirt bike example. So here's another picture of me riding my dirt bike. And looking at this here, this is like the land that I'm riding on. It's not hilly, it's not going up, I'm not going down. I'm flat the whole time. There's no slope here. This is a horizontal line. That means that this is a zero slope. So one way to check it is to imagine that you've got a dirt bike on the line or on the graph. Starting from the left to the right, just like we read, we want to put our pencil, our dirt bike, our finger on that line right here on the left. We want to just follow the line. And if you notice here, it's not going up, it's not going down. It's flat the whole time. That's how we know that this has a zero slope. The strategy of putting your pen, your pencil, your motorcycle, your dirt bike, whatever, on the line and then following it left to right is the strategy to figure out what kind of slope we have. That is to say, it's a good strategy for these first three until you get to this last one. And this is the weird one. It's called an undefined slope. An undefined slope is a vertical line. So it looks just like the y-axis. It's not positive because it's not increasing. It's not negative because it's not decreasing. And it's not a horizontal flat line. So the fourth and final type of slope is called undefined because the slope of this line does not make sense. If we look at this example with our dirt bike, we would put our dirt bike on the line. However, we can't even put it on the line. It would just fall right off. If you try to put the dirt bike on the line, it can't even fall. It can't even get on it. This is because it's too steep. It's too steep to even be defined. That's why we call it undefined. It's not defined and it doesn't make sense. It's not a zero slope because it's not flat. You can't even put the dirt bike on it. So this kind of line is called undefined. So go ahead and take a second, and I want you to practice identifying the type of slope shown by each line on the graph. So line A, line B, line C, and line D. On the right here, go ahead and identify, is it positive, negative, zero, or undefined? Pause the video now and press play when you're ready to check. Okay, so you should have just paused the video and tried this by yourself. We're going to start with line A. That's this flat horizontal line. Remember, horizontal is like the horizon. So left to right, it's flat. I want to start left of the line, and I want to put my dirt bike on it. When I move from left to right, it's not going up, it's not going down. It's a flat line, so it's got a zero slope. Let's find line B. It's this line. We always want to start on the left. It's just like we read. So when we look at a graph, we always want to start on the left of the line. We want to see what happens here as I go down the line. So I put my dirt bike on it, and it's going down. My dirt bike is going downhill. That's the clue that this is a negative slope. If the line is decreasing from left to right, when you put your finger, pencil, or your mouse or whatever on it, it's got a negative slope. Let's find line C. Let's try to put our dirt bike on it. We can't because it just falls off. This is an example of an undefined slope. A lot of people will confuse zero slope and undefined slope. But the difference is with a zero slope, I can put my dirt bike on it and I can travel across it. It's like flat land. Line C is undefined because I can't even put my dirt bike on it. If I keep my dirt bike straight like it should be, I can't put two wheels on it. There's no possible way to do that, so it's not defined. Line D is right here, and if we put our dirt bike on it, you can see when we move left to right that it would be traveling up. It's increasing, which means it has a positive slope. So that's the strategy for figuring out what type of slope you have. The strategy is going to be to put yourself or your little dirt bike or whatever on the graph. You want to physically put your finger, your pencil, whatever, on the graph of the line, and you want to travel across it left to right and see, are you going uphill? Are you going downhill? Are you flat the whole time? Or can you not even put yourself on the line because you'll just fall off? The dirt bike, the little Mr. C, put your pen or your pencil on it. These are the strategies that can help you remember the difference between undefined, zero, negative, and positive slope. So to review, slope is another word for unit rate, rate of change, constant of proportionality, rate, the change in y over the change in x, or the steepness of a line. There's four different types. There's positive, negative, zero, and undefined. So here's Mr. Slope Guy to help you remember that. So it would help you to take a screenshot of this page if that's something you want for your notes or just something that you can quickly reference. This might be something beneficial to you. All right, guys, that's it. If you made it to the end of this video, please comment which type of slope defines you. Today we learned about slope and rate of change. So now you should be able to identify the type of slope a line has from the graph. So now you should go ahead and go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye!